Jai Hind viewers, welcome to AKGEC Digital School. My name is Pankaj Singh. I am here to record a video lecture on cache memory. It is the topic of Computer Organization and Architecture COA Unit 4. So let's start. Here we have outline of our topic. First we know what is cache memory. Second we know what will be the locality of reference. And third one, the major topic of cache memory, it is the mapping techniques. How to map the cache memory to the main memory. So first we go to the definition of cache memory. So first we know what is cache memory. Cache memory, it is the fastest memory. As we read here the definition, cache memory is a small amount of fast memory reside between main memory and CPU, located on a CPU chip or module. Third, the fundamental idea of cache organization that will keep the most frequently accessed instruction and data in a fast cache memory. And the concept of cache memory is based on the property of computer programming known as locality of reference. What it is exactly? So first we know here cache memory. Cache memory is generally a part of, we can say, main memory that consists DRAM and SRAM. It constitutes max part of SRAM and a small part of DRAM. That is exactly cache memory. And how it located? As said in a sentence, the CPU, after that cache memory, and then main memory. So CPU first requests to the cache memory to identify any page or information or any instruction. If this instruction is not identified or located into a cache memory, then it will go to the main memory. So we use a specific term here. If a content that is requested or searched by CPU is find out into a cache memory, that's known as hit. If that content is not in a cache memory and find out in a main memory, that known as miss. So we will take here a diagram of cache memory and CPU as I draw earlier. In this figure, it is a neat and clean diagram you can see here. So CPU requests to the cache memory, and likewise this process will execute by the both end. Memory will transfer the content to the cache memory, CPU will access it, and vice versa will execute by the help of cache memory. Between CPU and cache memory, we use transferring of data here, word transfer, and between cache memory and main memory, the content transfer in the form of block, right? Because CPU requires the specific word that is required to execute an instruction. But in case of main memory and cache memory, there is no word exchange. It will exchange the complete block. So what is block, what is tag, set, we will discuss into a mapping technique. So what the problem will create here, because the cache memory have a small size and main memory large size. So it cannot contain or occupy all the data of main memory. So how it will done? That is done by the help of mapping technique. In mapping technique, we replace the old blocks to the main memory and pick up to the latest block requested by the CPU into the cache memory. Or this mechanism will try to keep all the latest information in a cache memory and write back the old information to the main memory. That is done by the help of mapping technique. In mapping technique, the block pick from main memory, copy to the cache memory, and the old block will transfer back to the main memory. So for doing this, we required mapping technique, as we go for it in a detail with the help of example. As we read some term or lines that are relevant to the cache memory, when the cache is full and block of word needed to be transferred from the main memory, some block of word in a cache must be replaced or determined by the replacement algorithm. Today we have only discussed the mapping techniques, but we also have replacement algorithms like optimal, restore, LRU and FIFO. We will discuss this technique in brief after the completion of mapping techniques. So as we heard the term locality of reference, what is locality of reference? So what is the role of locality of reference into a cache memory? Cache memory generally keep the content that are frequently used by the CPU or that is continuously requested by the CPU, so that it will be easily available into a cache memory for the execution of a instruction. So what is locality of reference here? Like analysis of program indicate then many instructions in a localized area of a program are executed repeatedly during some period of time, while the other are accessed relatively less. Example such what type of information or what type of instruction repeatedly execute, like loop in a program, nested loop, or few procedures calling each other repeatedly. They required same data repeatedly to execute a instruction or operation, or we can say specifically to a program in term of loop. So these information must be present into a cache memory, or that is the need of a processor. Such information keep in cache memory. So that is done by the help of concept locality of reference. Cache memory is based on the concept of locality reference. If active segment of program are placed in a fast cache memory, then the execution time will be reduced. It is a very simple thing. If the content that is required to execute the instruction in a cache memory, obvious it is easy and the execution time of an instruction will reduce. After that, the type of locality reference, it is of two type. After that, there are some other classification along with temporal and spatial, but if we talk in a broad spectrum, there are two type. Temporal locality generally used for the program, or we can say the data required in a loop, repeatedly call subroutines, setting of variables and reusing it many times. And spatial locality, if any item is referred, item whose address are nearby will tend to be referenced soon. Example, array and program code. We also need some data to execute a operation that is stored in an array or program code that is frequently needed, or we will identify that is required referred soon, or that will may be used in future for execution of program or instruction, that also keep in a cache memory. So these are the basic two type of a locality of reference. In temporal, we keep the data required in loop, subroutines, nested loop, likewise, and local variables as we specify. And in spatial, we keep array and program code. Here we mention the nutshell of cache memory. As I said earlier, the thing that find out within a cache memory is known as hit ratio, and the thing or the page is not find out into the cache memory is known as miss ratio. When the CPU refer to memory and find the word in cache memory, it is said to be produced as a hit, and if the word is not found into a cache, it is memory and it is counted as miss. Here we have a block diagram of all the process. As I said earlier, how the cache memory will find out the word into a main memory or into a cache memory. Here we have a look. Receive address to read from CPU. Is block content is available into a cache memory? If yes, then fetch the word and deliver to the CPU, and the process will complete. Problem create when the specific word is not available into a cache memory, then it will find out into a main memory, read the content, allocate cache line for main memory, then we will store the address into a memory, load memory main memory block into the cache line, and deliver array word to the CPU, and then the whole process will complete. So we can simply say that it is known as hit word, and the whole process is known as miss word. When word not available in cache memory, it will find out into the main memory and store its address and then hand over to the CPU. Likewise, when content is available in a cache memory, it will directly over to the CPU for their processing. So it is a complete process of a cache operations. As I said, CPU requests content of main memory, check cache for this data, if present get it from, then we can say it is hit or the access is fast. If it is not found in a cache memory, it is known as miss ratio. So now come to the main topic. As I said earlier, why we are going for the cache memory. In cache memory, the transfer of data from the main memory to the cache memory is known as mapping process. That is the most important part of a cache memory. So how it is done, how it is executed, how many part of a header it contain, it will discuss in detail with the help of example. So how it is done? It is done by the three methods. First one is known as direct mapping, second one is associative mapping, and third one is set associative mapping. We use few terminologies that we must know before going to the mapping. The term we use here, these are tag, block, and word. Okay, what is tag? Tag uniquely identify the group of blocks. Okay, what is block? It contains words from main memory. What is word? That is the actual content or data. So we will find out all this term in term of a bit, right? So we will discuss direct mapping, associative mapping, and set associative mapping. Before going to their numerical, we identify their header along with these terms tag, block, and word, and there are some unique properties how to identify which category of mapping is executed. In direct mapping, main memory address divided into three parts. What are these parts? First one is tag, block, and word, or we can write it like in a header form: tag, block, word. That is main memory address. In this mapping of main memory address to cache memory address is fixed. We will understand it in a diagram. What is associative mapping? Associative mapping. In associative mapping, main memory address is divided into two parts. It's a basic difference between associative and direct mapping. In it, we divide it into three parts, but in direct associative mapping, we divide it into two parts. These parts are tag and word. Only two parts, tag and word. Right? It is a main memory address. Third one is, it also contains a uniform property. It is dynamic in nature. What is the meaning of dynamic in nature? I will discuss in a diagram when we discuss the example. It is a static method. The location of each block is fixed here. And in set associative, main memory address is divided into three parts. What are these three parts? First one is tag, second one is set, and third one is word. In this method, we make a group of blocks known as set, tag, set, word. So it is a basic representation of these three mapping techniques in terms of their header, or we can say a memory address length, along with their terms like tag, block, word. Now we will discuss here graphical representation. In direct mapping, the position of main memory in a cache memory is fixed. For example, first of all, we divide the main memory into a number of blocks. We will discuss formula also here. 0, 1, 2, 3, so on till 15. These are blocks. If we have 15 blocks in main memory and we have 0, 1, 2 and 3, we have 4 blocks in cache memory and 16 blocks in main memory. So how mapping is executed in a direct mapping method? In direct mapping method, the location of a block of main memory is fixed in a cache memory. How it is fixed? And the way it is fixed is like this. The 0 will take the position into a 0 block, 1 will take the position in 1 block, 2 will take the position in 2 block, 3 will take the position in 3 block. After that, 4 will take the position in 0 block. Likewise, 5 will take the position in 2 block and 6 in block 2, 7 in likewise. If we talk block 0, or in number 1, 2, 3, 4. Here, if we specify, because in direct mapping it is fixed, it is not possible in this case the 15th will take the position in 0 or 1. That always go to their desired location, like cache memory block 0 will contain 0, 4, 8, 12. Likewise, 1 will contain 1, 5, 9, 13. 2 will contain 2, 6, 10, 14, and 3 will contain 3, 7, 11, 15. Hopefully you understand the trend, how it will store. We cannot store 15 into block 0, and we can't do this 13 to store into a block. It is not possible in this method. Each block have its fixed position in a cache memory. So how the tag and block is calculated? For example, we want to know tell me the block 12 of main memory will lie in which cache memory block. So it is very easy. We also know that we use a divide rule here. Block position, to find out block position we use simple mathematically concept we have used here. We want to find out 12th block position into a cache memory. So 12 will be divided by the number of block into a cache memory. How many blocks we have? We have 4. So we will find out it 3. We'll find out it by the help of divide it by 3, because 0, 1, 2, 3 we also consider here 3. It will go to 3, 4, 12. It represent 4. That means during the block 0 it have 4th position. Or if in a binary term, how to write 12? 12 will write here 8, 4, 2, 1, 0, 0. So these LSB define tag, and these define the position in a tag. Position 0, position 1, 2 and 3, right? So 0 tag contain 0, 1, 2, 3. Likewise, 1 tag contain 1, 5, 9, 13. If we want to know the position of 13, 13 divided by 3, so we will write it here 3, 1, and 4. So here 4 its position and 1 its tag number. So here for 12 we write it 12, 0, 4. So 0 is tag position and 4th is the position within a tag. Likewise we do to identify any of them. After that we will go in a set associative. In set associative we will discuss it here. In a associative, we will erase it here. Now take an example of in associative mapping, the content of, or we can say block of main memory can take position anywhere in a cache memory 0, 1, 2, 3 up to 15. So 0, 1, 2, 3. There is no boundation like direct mapping. In this method, the 0 block will take the position of 0 and also take the position in location 2. There is no boundation or there is no fixing of their locations. That's why this is known as associative method. In this, we don't require any tagging or block location. So that is represented by dynamic way by using two symbols like this. So in direct mapping, tag, block and word. In associative, it will convert into tag and word, because block is not fixed, so we don't require it in its memory address representation. So these two things will combinedly known as tag, because we can place anywhere into a cache. Memory location is dynamic. We can put 15 into a 1 and we can put 15 into a 2 location also. That's why it is known as dynamic method, and the direct mapping is known as static method. What is set associative? Set associative is nothing, just an extension of, or we can say hybrid model in which we use both approach, direct and associative. Okay, it is a combination of both approach. As per requirement, we use these methods. So in set associative, we use set of blocks. Minimum, we need 2 blocks. We generally explain in term of two-way set, 4-way set, that will mention in numerical or in description. Now come to the numerical. Hopefully these are the basic concept. Now we will take a example of all for common for all these problems. Here we have a cache memory size 2K. Okay, what we require to execute these things? First we identify from the numerical. First we need cache memory size. Then likewise we need main memory size, or we can say the parameter which we required in a tabular form. In a table form, we required cache memory and main memory parameter like size, block, word. We required these 3 parameters of both memories of cache memory and as well as main memory. As we pick from the numerical, we have size of cache memory, that is 2K. What is the size of main memory? It is 64K. How many number of block we have in this, or what word size we have? We have word size 16 word. Generally it is same for both cases, but once look over numerical, if it is different, we mention a different size for cache memory and main memory. It is 16 word. We will mention it same. Here it is a basic formula to find out the next value or the remaining value. We have a question mark over these values. So we use a simple formula here. Size of memory equal to number of blocks into word size. Very simple. If we know two values like size of memory and word size, we can easily find out the number of blocks. As we do here, first we found the number of blocks in a cache memory. It is calculated size of cache memory divided by block size, and we also calculated it here by using this formula. So when we divide the main memory size, that is 2K, by the help of 16, or we can say 2048 divided by 16, the answer will be 128 blocks. Likewise, if we execute the same thing for main memory, we will find out 4K blocks. What it is? It is the value of these blocks as I discussed in a theoretical part. As we see here, these are the values of blocks of cache memory and main memory. So the mapping is done in this way. We see here we have 40 block to 4095, meaning of 4K here 4096. We will take from 0 to 4095. Likewise, we have a cache memory block 128 and it is 0 to 127. The block 0 to 127 allocated to their location. After that, the same process will start. The 128 will allocate to 0. Likewise, 129 will allocate to block 1 and so on. So we can first find out the address of a main memory by the help of main memory length, that is 64K. That means log 2 of 64K, we'll find out it 2 to the power 6 into 2 to the power 10, that will be 2 to the power 16 log 2, that will be 16 bit. So we find out it here, that is of 16 bit as we hear. So first, the what is word size? Word size is 16 word. When we make a log 2 of 16, how much bit it required? That is 2 to the power 4. The word size 4. Okay. Likewise, what is block? Block always mention cache memory block. How much it is? That is 128. When we put 128 into a log 2 of 128, that will be a 2 to the power 7. That means 7. What is tag? As we say, the remaining bit is tag, but tag is calculated by the formula main memory block divided by cache memory block. Okay, so it's 4K divided by 128. So that will be 2 to the power 2 into 2 to the power 10 divided by 2 to the power 7, 2 to the power 12 divided by 2 to the power 7, that is 2 to the power 5. So we have here tag bit 5, block bit 7 and word bit 4. Similarly, in associative mapping, as I said earlier, we only calculate the word size. The remaining, it is of total 16 bit. We know the word size, it will contain 4 bit. The remaining will be a tag. Okay. And in set associative method, by default, we will consider a two-way set. So we divide, what is set will be size of block, cache block, divide by 2, that is 4, 2 to the power 7 divided by 2, that is 2 to the power 6, it is 6. And what is tag? Main memory block divided by cache memory block, that will be 2 to the power 12 divided by 2 to the power 6, 2 to the power 6. So it is a basic difference between these three methods. In direct, it is 5, 7, 4. In associative, it is 12, 4. Thank you. Hopefully you understand this topic. We will meet in a next slide.